For number 1, you needed to solve this, distribute, combine your like terms, and then get all of your variables on one side and your constants on the other. Remember that at this step, after you combine your like terms, how you do this, the order doesn't matter. So if yours doesn't match mine, don't erase. As long as you got x equals negative 1. Good. For number 2, you needed to evaluate this expression for 2 variables. Put in -7 and 2. Solve the inside. Make it positive because you're dealing with absolute value signs. And then multiply. Or if you put that in your calculator, it would have done all of that for you. Domain and range, well, this one just asks for domain, but that's something you probably have to use back to for. So remember that your domain is all of your x values. In this, as we're looking furthest left to furthest right, this keeps going up and to the left, and this keeps going up and to the right, which means it keeps going in both directions forever and ever. And when that happens, it's all real numbers. This first one is in set builder notation. X is an element of all real numbers. And the second one is in interval notation. From -infinity to +infinity is all of your x values. Or your x values could be anywhere in that. Do we have questions on those 3? On the back, you need to solve number 4 for y. Get it by itself. So subtract your ax terms to the other side, divide everything by b, and you're going to get y equals 2 ax all over b. Number 5, you needed to use the distributive property, so multiply by -5. So you'd get -5x plus 45. Do we have questions on those? Before we get into notes today, look at your course calendar. Everyone should have one. Especially because it is no school November and dates are weird. Just so you know when we have class, when things are due, things like that.
How many days do this month? How many days do you have this month?
My days and your days are different because I'm counting for 2. That big. Look and see when Khan Academies are due, Delta Mass are due. What I tried to have done is like what we do today, the Khan Academy will be due Friday. And then what we do Monday will be due on Friday, I think, as well as Wednesday. But then what we do the following week isn't due until that following Friday or something like that. Also look and see when your quiz and test will be. I've also put it on the board. So we should be done with this unit before we all go off for Thanksgiving break. If your break is going to extend to the week before break starts, you'll just have to make up your test when we get back. at some point. Speaking of tests, I know last time I saw you, we took the Unit 2B test, so the parallel lines, the linear regression, and word problems. If you were not here that day, so you didn't get a chance to take it, or you didn't get a chance to finish it, come see me before or after school. So today, that would just be after school. Friday, that would just be in the morning before first period. And then next week, Monday, Tuesday, and Wednesday, before and after school, only before school Friday. To come get that done. At the end of this week, I did not put in zeros for missing tests because we're not here, we didn't finish. At the end of this week, I will be doing that. So if you've not finished that, just know that zeros will go in, but once you finish it, I'll take them out. And that all of this stuff goes on the second marking period, so the one we're in now. Do we have any questions on any of that stuff? So our new unit is on systems of equations. So in previous units, we were talking about just solving equations, where there was one. A system of equations is more than one. If you go into Algebra 2, I think there's a unit where you're solving 3, but we're just going to deal with 2. Again, this may be familiar to you, it may not, but we'll go at it either way. So before we get into the actual how we find the solutions and things like that, you should have these notes somewhere in the papers on your desk. On this front page, we are given some systems of equations. We're given some ordered pair that's supposed to be the solution. And we have to determine, is this an actual solution or not? So in a regular equation, if we were given like some answer, x equals whatever, for an equation, and if we had to determine, is this a solution or not, we would put it in, see, does it work? If it works, it is. If it doesn't, it's not. Same thing here. We're going to put this ordered pair into both of these equations. If it works for both, then it's a solution to the entire system. If it does not work for both, then it can't be a solution to both, to the system. So for number 1, remember that this is your ordered pair, x, y. So we would put 2 in for x. I'm going to start with this first one. I'm sorry, I said 2 in for x, but I meant 2 in for y. And 3 in for x. And then I'm going to simplify the right side and see, does it equal to negative 1/3 times 3. These really cancel, and you're just left with negative 1. Negative 1 plus 3 is 2. So I can say that works. But just because 1 works doesn't mean it's automatically a system. We have to still check the other one. So we're going to do the same thing, put 3, 2 into the second equation. So 2 equals 2 times 3 minus 4. Simplify the right side. We have 6 minus 4. 6 minus 4 is 2. So I can say both of these work, or this works for both. So this is a solution for this system.
Match make heaven.
Before we do number 2, does anyone have any questions on that process? How we figured that out? Or anything else? Yes, Caleb.
I just figured.
the same thing for number 2. Put 2 and negative 10 in. And see, does this work for both? This would give us negative 6 minus 4, and negative 6 minus 4 is negative 10.
God bless you. God bless you.
Do the same thing for the second equation. Put in negative 10. We get negative 10 equals 8 plus 30, which is 11. Negative 10 does not equal 11. So this would not work. So this cannot be a solution. Both work, it is one. If one or both don't work, it cannot be one. Questions on that process? I'm going to give you the next 5 minutes. You may not need that long to do 3 and 4. And we'll come back at about 1:18 to go over those. For 3 and 4, 3 was not a solution and 4 was. Do we have questions on those? So this is a good check method when you are graphing the system and then you get some solution just to make sure that it works, put it back in. If it works for both, then you're good. If it doesn't, then you messed up somewhere and you graphed it incorrectly. On that same page, you have 4 graphs where they are asking what the solution is. So if you are given a system, and we'll see this later, you're given a system of equations, and what we'll find when we actually start graphing this is that if they intersect, that is the solution point, and we would write whatever that intersection point is as the answer. So this would be negative 2, negative 1. So if this was like one of the previous examples, this would work for both, it would be a solution. What would the solution for number 6 be? Here at negative 1, negative 1. You're just looking at where do these 2 lines cross or intersect. Wherever that point is, put your x, put your y, that is the solution. For number 7, where is your solution? And number 8. The page on the back, I'm going to talk about kind of, but we're going to skip that page. So it gives you like a little diagram of the types of solutions, but it's kind of small. So we're going to redo those and make them a bit bigger. So skip to this page. And I'm going to pull this down so you can write in this. So for your system of equations, that definition says two or more equations with the same variables. And then the solution to a system, graphically, the point x, y, where the two lines intersect. So we saw that. We looked at two lines that crossed each other, found where that solution point would be. Algebraically is where that point, that xy, makes both equations true. So that's the first thing we did. If we put it in, it makes both equations true. It is a solution. If not, it's not a solution. So I'll give you a second as you write that down. So what we're going to see here in a little bit is we are going to be graphing equations and seeing what the solution is. There are three different types of solutions, just like when we were solving regular equations. One, none, infinitely many. Those still apply, but they apply a little bit differently because of how they're interacting. Anyone still need? In this type of solution, draw in this random graphs, your x and y axis. It may help you if you have like a pen and a pencil or like a pencil and a highlighter to draw these two different lines we're going to draw. I do have highlighters right there if you want one. I also have colored pencils if you want different colors and a colorful card. So I'm going to draw like two random lines. They don't have to be exactly like mine, but if we have two lines that intersect each other, wherever they intersect, as we saw in our other examples, there's going to be one solution that's going to be in order to their x, y. If we have parallel lines, so I'm going to draw in two parallel lines. We just finished talking about parallel lines in our last unit. What do we know about parallel lines? Caleb? They don't intersect. Well, they have the same slope, and they have the same slope. So if they never intersect, and to graph them, they have the same slope, they will have no solution. You can write that NS or a 0 line through it. Because in order to have a solution, they have to cross. These never cross, so they will never have a solution. The last one is the same line. So if I have some line like this, and then I have some line that's drawn on top of it, it has the same slope, has the same y-intercept. It's the exact same line. This would mean they cross at every single point along this line. So this would have infinitely many solutions. So you can put S or the unity symbol. But these are the three types of solutions you could get. One, none, or infinitely many. And they have to be one of these three. Really quickly, I'm going to show you the steps to solving these, and then we're going to actually go through and solve these. So these steps are, one, rewrite the equation in slope-intercept form if it's not already, or if they're not already. Two, graph the lines. After we graph both lines, we should be able to see what type of solution it has, whether it's one and they intersect, none and they don't intersect, or infinitely many because it's the same line. We'll also be able to see that kind of through the equations, but we still have to graph them because we are solving the system, and the way we're solving it is by graphing. Before we start graphing, if you would like a ruler, right behind Mr. Northrop is a colorful heart, and there are rulers and color pencils. Feel free to grab one. You need your lines as straight as possible, so rulers are good. Also, like I said earlier, drawing the lines in two different colors, pen and pencil, pencil and highlighter, whatever color pencil, if you want to use that, will help me kind of see your two lines unless you like make one distinctly. Anyone still need this part? Let's actually graph some of these. We're going to start with number one. Are you looking for the color pencils? Which one? They're in like pencil cases in the drawers. So whichever drawer, if you pull it out, there should be a pencil case in there. The like navy blue, light blue things, containers. You may have to pull it off. Like rectangular boxes. Okay. So for this one, I'm going to do this in two different colors so we can keep them distinct. Before even graphing this, as I look at these two slopes, I can tell they're not the same. So these cannot be parallel lines, which means no solution is out. These don't have the same slope and the same y-intercept. So infinitely many solutions is out. This will have to be one solution. We just have to figure out what that is. For this first one, in order to graph our lines, thinking back to that unit, start at your y-intercept of -8. These are 10 by 10. Your slope is a +1. Remember, for positive directions, you can go up and to the right or down and to the left. So you're going to do that and fill up your graph. You want as many slope points as possible. So I'm going to start going up one and right one. So up one, right one. Plot a point at every up one, right one. Found your Y-intercept. And then go back to your Y-intercept and go down one, left one as many times as possible. Good. Once you have all of your dots, go ahead and connect your line. Make it as straight as possible. Then do the other one. I definitely put that as. Okay. So this one would have a y-intercept of +1 and a slope of -2. So you can go down 2 and right 1, or up 2 and left 1 as many times as possible. You can go up 2, left 1 first. And then go back and go down to right 1. As you're drawing this, you'll end up at some point where they overlap. Finish your line and then you can go back to that point. Once you have all of your dots, you can draw your line. And then if it helps you, you can like circle or highlight the point where they intersect. And count where that would be. So 1, 2, 3, +3, -5. The process itself is not difficult. It's just you have to remember how to graph your lines. Don't mess up your slope. Make sure your slope is going in the right direction. And then make your graphs as straight as possible. That way they intersect at the right point. Because if your lines aren't straight, it could intersect at a point that's not actually your solution. Do we have any questions on that one? Do a few more. Let's do 4. For number 4, one of the equations is not in slope-intercept form, so we have to get it in slope-intercept form, convert it. So we need to subtract our x to the other side. Change the order, so it's -x plus 4. And then divide everything by 2. When you divide, remember that the negative x is really -1x, so this fraction would become -1/2 x plus 3. And we can graph that one. Start at your y-intercept of +2. Your slope is a -1/2. So you're going to go up 1, left 2 as many times as possible, or down 1 and right 2 as many times as possible. Build your graph. And graph your line once you have filled up your graph. For this one, as we're looking at the slope and the y-intercept, I see that they're exactly the same. What type of solution is that going to give us? Infinitely many. So you can put IMS or infinity sign. I guess. But you do still have to show me that you somehow drew both graphs. You don't have to redraw that one again. You could do one of two things. If you drew one, you can draw over this one in highlighter. And that would show me that both of them are there. If you don't have a highlighter, what you could do is with either another color or different types of arrows, you could extend this line. Maybe make it a double arrow or something to show me that there are two lines there. Either one of those works. I just somehow need to see that there are two lines there. Questions on that one? We'll do number 6. For number 6, we again have this equation that's in standard form, so we need to get it in slope-intercept form. So subtract x to both sides. And I went ahead and switched the x and the constant. Divide everything by -1. So our new equation is y equals +x minus 2. Before we graph this, as we're looking at these two lines, they have a different y-intercept and the same slope. So these are going to be parallel lines. What type of solution would that be? So we could write the answer without graphing it at first, but we do still have to graph it. Whether that's you do the graphing part first and then find the answer, or vice versa. We do this one in this color. Start at my y-intercept of -2. My slope is 1, so I'm going to go up 1 and to the right 1 as many times as possible. And then down 1 and left 1 as many times as possible. And once you filled up your entire graph, go ahead and connect those points, make a line. I don't remember if I said this, but make sure your line has arrows, because the lines keep going on forever and ever in both directions. And then graph the other one. So this would be at positive 5. The slope is also 1. So up 1, over 1 as many times as possible. Fill up your graph. And then down 1 and left 1 as many times as possible until you graph that way. And then draw your line. I can see that we have two parallel lines. They're never going to intersect, so they cannot have a solution. We're going to do one more, and then you'll have time to practice. Let's do number 5. So with questions like number 5, number 8, one, you have to remember which type of line you need to draw, if it's just a y equals a number or an x equals a number. And then you also need to solve this. So I'm going to solve this one first and then deal with this one. Subtract x on both sides. And divide everything by 3. So that equation would become y equals, this is negative 1x, negative 1/3 x minus 5. And then we can plot that y-intercept. Our slope is negative, so we can go up 1 and left 3, or down 1 and right 3 as many times as possible. And draw that line. If you need to, you can rewrite this so you remember, is x or y a horizontal or a vertical line? So for y equals those four are horizontal lines. So at -7, I'm going to draw a straight horizontal line. And then looking at the equations, I knew that these two did not have the same slope. One had a y and an x, one just had a y, so they could not have had the same slope. So these could not have been parallel or on the same line. We're going to have one point that was a solution, and that point was at Do we have any questions on this process? There are 3 ways to solve systems. Graphing is one of them. Of the 3, I feel like graphing is the easiest. It just takes the longest because you have to fill up your graph. For the remainder of class, you have a couple different things you could be working on. The rest of these examples, so you can go back and do these examples that we did not do on this page and this number 2. Along with, we skipped these 4, but if you want to go back and do those, you're more than welcome to. And then there's a practice that you go back to. You have 2 Khan Academies due on Friday. They are both on systems of equations by graphing. And 1 Delta Math on solving systems by graphing that is due on Monday. You have different things you could be working on. Make sure you're working on something math related. If you have questions, we'll be walking around. But you now have this time to work.